Hi, it's MP the tutor here. And today we are looking at functions to do with like f of x and g of x and stuff like that. So here we have two separate functions. If you've got more than one function, we start going through letters f of x, g of x, h, I, j, k, but we don't tend to have more than like two or three, so f, g is what we're going to have here. So if I had a question which was find f of 6, for example, all we're doing is we're going to replace the 6 with the x, or the x with the 6. So we have f of 6 is the same as 2 times by 6 plus 3, which is 12 plus 3, which is 15. Or g of 4, for example, well, that is the same as 4 squared plus 5. 4 squared is 16, and 16 plus 5 is 21. Or what about if we have g of minus 6? Well, that's minus 6, but in brackets squared, plus 5. Well, minus 6 squared is 36, so that's 36 plus 5, which is 41. Let's zoom out on that a little bit. So we have g of x equals x squared plus 5, and for g of 6 minus 6 is 41. So here we have a slightly different question. So we have our f of x and g of x, and we're keeping them the same. But this time I want to find f g of x. Now what we're doing is we're going to plug this function here into our f of x function. So our f g of x is 2 lots of x squared plus 5 plus 3. So what does that equal? We're going to expand that out. You get 2x squared plus 10 plus 3, or 2x squared plus 13. So this next one's basically the same, but I'm going to do it the other way around. So this time it's g f of x. So what we're doing is we're going to plug the f of x function into place our x here. So our g f of x is in brackets 2x plus 3 squared plus 5. So I'm going to do a little multiplication grid to expand out that 2x plus 3. 2x times 2x is 4x squared. 2x times 3 is 6x. Then we have 2x times 3 is another 6x. And then we get 9. So then our g f of x is 4x squared plus 6x plus 6x plus 9 plus our 5, or g f of x. We're going to collect all the terms together, and you get 4x squared plus 12x plus 14. So if you look, if I zoom out, there we go, get the right bit. So if we zoom out to that, here you have f g of x is 2x squared plus 13, and g f of x is 4x squared plus 12x plus 14. Now you can see they are different because of the order you do it in. So f of x is 2x plus 3. Find f with a little 2 at the top, or f squared of x. So this one's slightly quirky, because what we really got is f squared of x. That's the same as f of x. So what we're doing is we're going to plug our equation into itself. So our f squared of x is 2 lots of 2x plus 3 plus 3. So you're replacing the x with itself. So then that is 4x plus 6 plus 3, or our f squared of x is 4x plus 9. Now, obviously, we could then continue that further. So you could have f cubed of x, which you then plug the original equation into itself. So here we have f squared of x is 4x plus 9, and f of x is equal to 2x plus 3. Well, then f cubed of x is f of x, which I could then basically have an f of squared of x. So basically what we're doing is we're going to plug this into here. So we're kind of replugging the 4x plus 9 into our 2x plus 3. So our f cubed of x would equal to 2 lots of 4x plus 9 plus 3, which is 8x plus 18 plus 3, which is 8x plus 21. So don't think they're ever going to go beyond f cubed, but obviously you could keep going and keep going if you really fancied it. So here we have the same function, f of x is 2x plus 3, but we want to find f to the minus 1 of x. Well, this bit here is actually now means the inverse function. So the way we go about this typically is you go y equals 2x plus 3. And we're going to rearrange to basically make x the subject. So we get rid of this 3 first of all. So you have y minus 3 equals 2x. And then we get rid of that 2 by dividing. So you have y minus 3 over 2 equals x. Now then what we end up doing is we replace the x with f to the minus 1 of x equals x minus 3 over 2. So this is our answer. So we can check this by plugging in a number. So if I had f of 10, well, that's 2 times 10 plus 3. 2 times 10 is 10. Well, 2 times 10 is 20, plus 3 is 23. Well, f to the minus 1 of 23, well, that's 23 minus 3 over 2. 23 minus 3 is 20. Divided by 2 is 10. So they are the inverse or the opposite of each other. So here we have another question where it says find the roots of f of x equals 2x minus 10. Now what does that mean? Well, the roots is basically when f of x equals 0. So all we do is you go 0 equals 2x minus 10, and then we solve for it. So a lot of these will be quadratics or cubics, which you have to go back to the previous chapter for quadratics when it equals 0. But in this case, we just go, I'm going to add 10 to get rid of 10. So 0 add 10 is 10 equals 2x. And then we divide by 2. So then you end up with 5 equals x. There we go. That's your answer. So a very simple thing is actually when does it equal 0? Here, find the roots of 2x minus 10, which is 1 equals 0. So find the roots of f of x given f of x equals 3x plus 7. So what you do is you go 3x plus 7 equals 0. 3x equals minus 7 because you just take away the 7. And then x equals minus 7 over 3. Boom, that's it. Very simple. Now you could have obviously quadratics, which we're going to do in a moment. Let's have a little look at this next one. So this is find the roots of f of x given f of x equals x plus 4 in brackets and x minus 7 in brackets. So all this really is 0 equals x plus 4, x minus 7. And it might be worth going back to quadratics in 2.1 if you're not 100% sure on these things. But really, what we've got is x plus 4 equals 0, or x minus 7 equals 0. So if one of our things multiplying together is 0, the other bit we don't really care about. So x plus 4 is 0. So what is x? Well, we can take away the 4. So you get x equals minus 4. And then we just add 7. So we get x plus x equals 7. That's our two answers. Nice and simple. It even factorized it for us. So here's another nice one where it says find the roots of f of x given f of x equals x brackets x plus 3, x minus 5, and x minus 8. All of them each in brackets. So again, we have 0 equals x brackets x plus 3, x minus 5, and x minus 8. And then we just treat each one to be equals. So either x equals 0, x plus 3 equals 0, x minus 5 equals 0, and x minus 8 equals 0. The first one's kind of done for us because x equals 0, there's nothing to do. We have x plus 3 equals 0, so that means that x equals minus 3. X minus 5 is 0, so that means x equals 5. X minus 8 is 0, so x equals 8. There are 4 answers here because there are 4 roots. So here's another very similar one, but here we have just a normal quadratic, which has got x squared plus 3x minus 10. So find the roots of f of x, given f of x squared minus 3x minus 10. Again, you just do 0 equals x squared plus 3x minus 10. This is factorizable, but also you can solve by the quadratic formula. So you have 0 equals, and you have brackets, we have x plus and x minus. We need the factors of 10. 1 times 10 and 2 times 5. What number minus the other one gets you a plus 3? That's a plus 5 and then a minus 2. So then we have our normal x plus 5 equals 0, or x minus 2 equals 0. That means that x equals minus 5 or x equals 2. That's our two answers. And you can do the same thing with cubics, or you can have hidden quadratics. And that's basically it for these root things and functions like this. If you're not sure, so for example, question 7, you've got some hidden quadratics in exercise 2e, then you'd be worth going back to look at the quadratics, which is 2.1, which I'll put in the description. So I've put exercise 2e on screen. So hopefully you'll spend a moment now, have a go at these questions. Obviously, there's a few hidden quadratics, or not that hidden, in question 7. There's a bit of completing the square, which is from the previous exercise for question 6. But have a go, and hopefully your answers will be correct. So I'll put the answer on screen now. So you spent a moment marking it. Hopefully you've done all right. And I hope to see you in the next video. So next video will be on quadratic graphs and sketching them and how to draw them.